So if you were to take a hacksaw, right, and just cut open a $20 beginner pickleball paddle from one of those big box stores.
Oh, yeah, one of the cheap plastic ones.
Exactly. And then you do the exact same thing to a premium, like $300 professional paddle, you would actually find something completely paradoxical.
It really defies basic intuition, honestly.
Right, because inside both of them, you're looking at the exact same thing. It's just this sheet of relatively cheap plastic honeycomb.
Yeah, nearly identical internal architecture, basically. Just this honeycomb lattice.
But then you take them out onto the court, and I mean, one plays like you're swinging a heavy wooden cutting board, and the other acts like this highly tuned, almost illegal rocket launcher.
Which is wild, right? You have the same core yielding wildly different physical results in the real world.
Hmm.
So you go online to figure out why, and you just hit an absolute wall of noise.
Oh, totally. It's overwhelming.
Hundreds of brands, extreme price variances, and this whole dictionary of confusing buzzwords like thermoformed or peel ply or swing weight.
Okay, let's unpack this. Our mission for this deep dive is to get past all that marketing hype. We aren't just going to list brand names here.
Right, because that doesn't actually help anyone.
Exactly. We're going to deconstruct the actual physics of the paddle. The goal is to help you decode all that jargon, solve the whole Goldilocks problem of pickleball gear, and find the equipment that actually matches the physics of your specific swing.
Yeah, to really understand these space-age materials that dictate the modern game, w- we we kind of have to look at the problem early players were trying to solve in the first place.
Right, before the space age stuff.
Exactly. From 1965 all the way up to like 1984, the technology was essentially just loud, heavy plywood.
You were basically out there swinging a dinner plate.
Totally. I mean, it had zero finesse, and your arm would be completely dead after just an hour of play.
Yeah, I guess the only real consumer advice back then was just, picking the paddle that wouldn't give you splinters.
Basically, yeah. But that all changed overnight in 1984, and it all traces back to an industrial engineer at Boeing named Arlon Pardo.
Oh, wow, an aerospace engineer.
Yeah. He was dealing with these incredibly lightweight structural panels used for aircraft flooring, and the fundamental design of those panels was a honeycomb core sandwiched right between fiberglass skins.
So he just looked at an airplane floor and thought, that looks like a good paddle.
Kind of, yeah.
Hmm.
He realized this aerospace flooring solved every single mechanical issue the wooden paddle had. I mean, it was incredibly light, structurally strong, and remarkably rigid.
That's amazing.
So he cut a paddle shape out of this Boeing floor panel, and the game was just fundamentally transformed. That exact honeycomb structure, born from literal airplane scrap, is still the DNA of almost every single paddle sold on the market today.
Okay, so since almost every paddle shares that same honeycomb airplane DNA, the obvious question is, why do they feel so incredibly different on contact?
Well, the honeycomb core is essentially the engine of the paddle.
Yeah.
But not all engines are tuned the same way.
Right, makes sense.
Today, the vast majority of those honeycomb cores are made from polypropylene, which everyone generally just calls polymer.
Okay, polymer.
Yeah, it's a highly durable, relatively soft plastic. So when you see a paddle marketed as having a poly core, it basically means the engine is designed to absorb energy.
Meaning it's softer.
Exactly. It's quiet, and it gives the player a tremendous amount of control because the energy of the incoming ball is dispersed right through those plastic cells.
Wait, okay, but I definitely still play against people whose paddles sound like a high-velocity gunshot echoing across the park.
Oh, the really loud ones.
Yeah, if polymer is the standard because it's quiet and absorbs energy, those incredibly loud paddles must be using, like, a completely different engine block, right?
Oh, absolutely. That aggressive high-pitched crack usually comes from a Nomex core.
Nomex? What's that?
It's an older, highly rigid technology. Think of it kind of like a dense cardboard material that's been soaked in industrial resin and then baked really hard.
Oh, wow, so no plastic at all.
Right. When the plastic pickleball hits a Nomex core, the surface doesn't yield even a little bit. The ball just pops off instantaneously.
So that gives you a ton of speed, I imagine.
Raw speed, yeah.
Yeah.
But Nomex has largely fallen out of favor in the modern game because it severely lacks control.
Mm-hmm.
I mean, if you're trying to execute a really delicate, soft drop shot into the kitchen, a Nomex paddle feels like you're playing with a slab of marble.
Yeah, that sounds terrible for the short game. Let's stick with the polymer core then, since that's the modern standard. I know manufacturers tweak the feel of that polymer engine by changing its thickness, right?
Yes, exactly.
Because you constantly see millimeter measurements thrown around in the marketing usually, like 16 millimeters and 13 millimeter.
And core thickness is arguably the most critical variable that players just totally misunderstand. A 16 millimeter core is thick.
Re.
Think of it kind of like a plush luxury car suspension system. When the ball strikes the face of a 16 millimeter paddle, that thicker plastic honeycomb has more room to compress.
It absorbs the impact.
Yes, it allows the ball to actually sink into the face for a fraction of a second longer.
And that extra fraction of a second is everything for stability, you know? And then, like, if your opponent blasts a drive right at your chest and you just need to absorb all that kinetic energy and block it softly over the net.
Exactly. That thick 16 millimeter suspension is doing all the heavy lifting for you.
Okay, so then on the other side of the spectrum, you have the 13 millimeter core.
Right. And going back to the car analogy, this is a stiff, rigid sports car suspension. Because the core is thinner, there's just far less physical material to compress. The surface doesn't yield to the ball.
Wait, if the 13 millimeter core is thinner and stiffer, doesn't that mean the paddle absorbs less energy?
Yes, exactly.
So it forces the actual plastic pickleball to do the deforming.
That is the exact mechanism at play, yeah. And this exposes a really counterintuitive truth about sports physics.
Oh, how so?
Well, a lot of people assume a thicker, chunkier paddle would hit the ball harder because it just looks heavier.
Yeah,
right?
That's what I would think.
But power comes from stiffness, not mass.
Mm-hmm.
When you swing a rigid 13 millimeter paddle, the paddle doesn't flex. The plastic pickleball takes the absolute brunt of the impact.
Oh, so the ball squishes flat against the face?
Exactly. It squishes flat against the carbon. And because plastic inherently wants to return to its spherical shape, the ball violently snaps back.
Yeah.
That snapping action off a rigid wall, that is where the massive power and pop comes from.
Ah, I see. But, I mean, there has to be a trade-off for that free power, right? If the paddle is that stiff, a mishit is going to feel terrible.
Oh, it does. A thinner core has a significantly smaller sweet spot. If you hit the ball off center, near the edge, a 13 millimeter paddle is going to twist violently in your hand.
Whereas the plush 16 millimeter core would absorb some of that uneven torque.
Precisely.
Okay, so we have the engine figured out. A thick core absorbs the ball for control. A thin core squishes the ball for power. But, if the core is just absorbing or reflecting energy, it can't really generate spin on its own.
No, it can't.
Which brings us to the face materials, essentially the tires where the rubber meets the road.
Yeah, the material spanning across that honeycomb core changes the dynamic of the game immensely, specifically regarding friction. Let's look at the most common entry-level material first, fiberglass.
Usually find this on mid-range paddles, right?
Yeah. And fiberglass is inherently flexible. When the ball hits it, the face actually flexes inward, stores energy, and then snaps back out.
It sounds kind of like a bow and arrow.
It really is.
The fiberglass bends back, loads up the tension, and then just fires the ball forward. I imagine for a beginner with a slow, hesitant swing, that flex gives you a bunch of free, effortless power.
Oh, totally. The ball absolutely rockets off a fiberglass face. But the major limitation is unpredictability.
Right, because of the flex.
Yeah, because of that Boeing effect, fiberglass can act like a trampoline with really inconsistent tension. You might hit a hot spot on the paddle and accidentally send the ball 5 feet past the baseline when you barely even swung your arm.
Which explains why you rarely see fiberglass on the professional tour. What you see dominating the highest levels right now is raw carbon fiber, specifically T700 raw carbon.
Yes, absolutely everywhere.
But when you look at it closely, it doesn't have that classic woven checkered fabric look,
Yeah.
It has a dull, highly gritty surface. When I first felt that texture, my immediate thought was that a manufacturer just spray painted some cheap sandpaper grit onto the plastic.
Which you'd think would inevitably wear off after a month of hard play.
Exactly.
That is a very valid concern, but true raw carbon texture isn't an additive. It's not a spray-on grit. It is a structural feature of the manufacturing process itself.
Wait, really? How does that work?
So, when they are curing the carbon fiber under extreme heat, they press a tightly woven fabric called peel ply directly into the resin.
Okay.
And once the resin hardens, They literally peel that fabric away. It leaves behind this negative impression. Basically, a microscopic, permanent mountain range of texture stamped directly into the face.
Oh, wow. So the grit is actually the cured resin itself standing up in these tiny peaks.
Exactly.
And unlike fiberglass, carbon fiber is incredibly rigid, so it acts like a brick wall, eliminating that unpredictable trampoline effect.
Right. It offers pure consistency. And because of those permanent peel-ply peaks, the face literally bites into the porous surface of the plastic ball.
So you get massive spin.
What's fascinating here is if you want to hit aggressive looping drives that clear the net and suddenly dive bomb right at your opponent's feet, you absolutely need that friction. The entire geometry of high-level play has shifted because the top tier of the sport is now entirely dictated by the massive topspin that this specific raw carbon material enables.
That makes total sense. Okay, so we know what the paddle is made of inside and out now. But that physical shape, the actual silhouette of the paddle, that changes the physics of the swing drastically, too.
Yeah, big time.
When I started playing, every paddle looked like a rounded square with a little handle. Now I look across the court and see people wielding these long, thin swords.
It's a whole different landscape. Manufacturers have basically categorized shapes into a few distinct buckets. You have the wide body, which is short and fat.
Right.
It offers a massive side-to-side sweet spot.
Yeah.
It is incredibly forgiving, making it perfect for defensive players who just want to ensure they get solid contact, even if their mechanics are slightly off.
And then you have the elongated shapes.
Exactly.
Those elongated paddles are usually pushed to the legal limit, which is 16.5 inches long. They give you a ton of reach, which is great for digging out low balls. But the real physics advantage is leverage, isn't it?
It's all about leverage.
Because the weight of the paddle is stretched further away from your hand, it acts like a longer lever. So when you swing, the tip of the paddle is covering more distance in the same amount of time, which means it's moving significantly faster through the air.
And that tick speed generates heavy power. But, physics dictates you cannot get something for nothing.
There's always a catch.
Always. The catch to that extra leverage is a metric called swing weight. This is a concept the pickleball world borrowed heavily from tennis and golf.
Right, swing weight.
Yeah, and swing weight is entirely different from the static weight you see if you just drop the paddle on a kitchen scale. Swing weight measures the resistance to motion, basically how heavy the paddle actually feels while you are swinging it.
Okay, think about picking up a standard hammer.
Perfect analogy, yeah.
If you hold it by the bottom of the handle, the normal way, all the mass is situated at the far end. So it feels heavy to lift, and it's slow to swing. That's a high swing weight, and that's exactly how an elongated paddle operates.
Exactly.
But if you choke all the way up and hold that exact same hammer right next to the heavy metal head, it suddenly feels incredibly light, and you can dart it around quickly. That's a low swing weight, which is what you get with the standard or wide body paddle.
That's spot on. So if you were in a high-speed hand battle at the net, reacting to volleys blasted right at your face, an elongated paddle with a high swing weight might feel really sluggish.
Yeah, you might get jammed up.
You literally cannot move your hands fast enough to reposition the paddle. A standard shape, even if it weighs the exact same on a scale, will feel much faster and more maneuverable in a firefight.
This geometry also dictates the handle length, doesn't it? I see tennis converts at the park swinging out of their shoes, naturally trying to hit two-handed backhands.
Oh, all the time.
If they are using a standard 5-inch handle, their bottom hand is basically gripping thin air. They absolutely need an elongated paddle specifically designed with a 5.5-inch handle.
Yeah, even if it means the actual face of the paddle gets smaller to compensate for the longer handle.
That's a fair trade-off for them.
Right. For a tennis player, being able to cleanly snap that two-handed swing is far more valuable than an extra half-inch of blocking surface. Conversely, if you have a table tennis background, where you might rest your index finger directly on the back of the paddle face for control.
Oh, yeah, the penhold grip or whatever.
Yeah, exactly. For them, a long handle is a complete waste of space. You want a short handle to maximize the hitting area.
Okay, so we've got the long paddles for leverage, wide ones for defense. But human nature dictates that players always want both.
Naturally.
They want the massive tip speed of an elongated shape, but they don't want the tiny, unforgiving sweet spot that usually comes with it.
And that exact desire birthed an absolute arms race in manufacturing. 2 years ago, we saw the biggest technological shift since the honeycomb core. Thermoforming.
Thermoforming.
Yeah. To understand why thermoforming is so radical, we have to look at traditional cold-pressed paddles. Those were built like a basic sandwich.
How so?
Well, you take the honeycomb core, glue a carbon face sheet on top, glue another on the bottom, and just press them together. The weak point of that design is the exposed honeycomb on the edges.
Oh, because it's just an open sandwich.
Right. When you hit a ball off center, the whole paddle twists, and a lot of kinetic energy is lost right through those weak sides, which is why they just slap a flimsy plastic edge guard around it.
So thermoforming completely throws that cold-pressed sandwich out the window. Instead of just gluing sheets to the top and bottom, the manufacturer fully encases the honeycomb core in a structure of carbon fiber and resin. They put the entire assembly into a mold and heat press it into a single, solid, unibody structure.
It's all one piece.
Right. The edges aren't a plastic bumper strip anymore. They are a solid carbon wall, which is often injected with high-density foam.
And that foam-injected carbon edge acts like a tightly strung tennis racket frame. It holds the perimeter of the paddle completely stiff.
Wow.
Because the edges are rigid, the force of a ball strike is distributed evenly across the entire face, rather than just bending the local area where the ball hit. This expands the sweet spot almost all the way out to the edge.
So the resulting power is just extreme.
Extreme. However, this radical heat molding process birthed a massive controversy in the competitive scene: delamination.
Okay, here's where it gets really interesting. Delamination sounds like a catastrophic failure, like, a tire blowing out on the highway. I assume it means the paddle just shatters and becomes useless garbage.
It's actually the exact opposite.
Wait, really?
Yeah. When the internal layers separate, like when the glue bond between the carbon face and the honeycomb core fails from the stress of thermoforming, the paddle doesn't become useless. It becomes far too good.
Oh, because the face is no longer anchored to the core.
Precisely. When that face sheet separates, it acts completely independently. It basically turns into a pure, unadulterated drumhead.
Oh, wow.
When the ball hits that loose face, the trampoline effect is massive, and the exit velocity of the ball spikes dramatically. It becomes a completely illegal rocket launcher.
How can you even tell if that happens?
You'll know a thermoformed paddle has delaminated because it starts making this terrible, crunchy shotgun sound when it strikes the ball.
That perfectly explains why professional players are formally challenging their opponents' paddles during high-stakes tournaments.
Exactly.
They aren't worried the paddle is broken. They suspect their opponent is wielding a super-powered, illegal weapon that's going to drive the ball past them at unsafe speeds.
Exactly. Now, reputable manufacturers have largely ironed out the delamination issue in the newer generations of thermoformed paddles. But the baseline stiffness of a unibody paddle raises a really serious physical toll.
Right, because it's so rigid.
Thermoform paddles are incredibly rigid, yeah, and that stiffness transmits high-frequency vibrations straight down the handle, right into your tendons. If you are a player prone to tennis elbow, you have to be very cautious approaching this new technology.
That's a great warning. Let's put all this theory into practice now. Say someone is listening right now, they've played maybe 5 or 6 times, and they just want to buy their first real paddle without getting ripped off. What is the baseline prescription for a beginner?
Okay, first rule: avoid the ultra-stiff thermoformed power paddles.
Too much power.
Yeah, they will be far too difficult to control when you are still developing your soft game. You want to look for a standard or hybrid shape with a low swing weight so you can maneuver it easily.
Makes sense.
You want a thick 16mm polymer core to maximize your control and give you that plush suspension feel. Try to find a raw carbon fiber face if it fits the budget, but whatever you do, avoid the cheap wood or aluminum options.
How much should they expect to spend?
You can easily find a fantastic, forgiving paddle that fits this exact profile for around $100.
Okay, what about a friend of mine who just switched over from high-level tennis? They hit the ball incredibly hard, they love staying back at the baseline, and they rely entirely on a two-handed backhand.
Ah, okay. That player needs an elongated shape with a handle that is at least 5.5 inches long.
For the backhand.
Right. And because they already have full fast swing mechanics deeply ingrained from tennis, they will actually thrive with a unibody thermoformed paddle. They won't mind the heavy swing weight because they're used to swinging heavy rackets anyway.
And what core thickness for them?
They could go with a thinner 13mm core to get that familiar stiff racket pop, or a 16mm if they realize they need to learn the softer, short game at the kitchen line.
Okay, and what about someone like an older strategic doubles player? They are incredibly smart, their court positioning is flawless, but maybe they don't have lightning-fast reflexes at the net anymore, and they really need to protect their elbow from flare-ups.
This player needs to prioritize a low swing weight above all else so their hands stay fast at the net. A lightweight wide body shape is ideal here.
To help with maneuverability.
Exactly.
Yeah.
And they absolutely need a thick 16mm core or even a specialized 20mm core to maximize shock absorption and sweet spot size. The focus is entirely on soft control, consistency, and joint protection, entirely sacrificing raw power.
Which naturally brings us to the reality of the price tag. I see paddles marketed as the ultimate weapon for $250. Is a $250 paddle genuinely 5 times better than a $50 paddle?
No, it is a textbook case of diminishing returns. A $50 standard paddle from a reputable brand will honestly get you 80% of the way there.
Really? 80%?
Yeah. The $120 to $160 range is really the sweet spot of the market. That gets you true peel-ply, raw carbon fiber, and solid structural construction. At that price, you are about 95% of the way to the top.
So what's the extra $100 for?
Paying $250 is just paying a premium for that absolute cutting-edge thermoforming tech, massive brand marketing, and extensive warranties.
Well, if you don't want to drop that kind of cash, there is a $5 hack that completely alters the physics of a cheaper paddle, right? Lead tape. I always assumed putting lead tape on a paddle was strictly for obsessive professionals fine-tuning their gear.
Not at all.
Yeah.
It is the single cheapest, most effective way to upgrade any paddle.
Really?
Yeah. If your paddle feels unstable or it twists violently in your hand when you try to block a hard drive, you just buy a $5 roll of high-density lead tape. You apply small strips to the bottom corners of the paddle face, down near the throat of the handle.
Wait, isn't adding weight defeating the point of buying a lightweight aerospace paddle in the first place? Why the bottom corner specifically?
It's entirely about where the weight goes. When a ball hits the edge of your paddle, it exerts torque on the handle, making it twist. By putting dense lead tape on the bottom corners, you increase the paddle's moment of inertia along its roll axis.
Okay.
This metric is called twist weight. That extra mass at the edges fights against the torque of an off-center strike, massively expanding the feeling of the sweet spot.
Oh, that's brilliant.
And because you place the weight down close to your hand, it doesn't dramatically shift the center of mass forward. It stabilizes the paddle without negatively impacting your swing weight or slowing down your hand speed at the net.
That entirely changes how I view paddle customization. So basically synthesizing this physical formula. Core thickness dictates your feel, the plush 16mm suspension versus the rigid 13mm wall.
Right.
Face material dictates your spin, with peel-ply raw carbon fiber being the undisputed king of friction.
Exactly.
The shape determines the balance of leverage versus elongated swords versus standard shields, and swing weight is the hidden metric determining how fast you can actually move the equipment through space.
That is the complete formula.
Yeah.
But I think it's vital to provide a humbling reality check here.
Oh.
All this aerospace engineering, the thermal molding, the peel-ply carbon, it is fascinating. But the paddle does not play the game. I have personally witnessed a 5.0 level professional player completely dismantle athletic amateurs while using a literal wooden spoon from a kitchen drawer.
Oh, man. A tough pill to swallow.
It really is.
If you are consistently popping up your dinks or driving your serve straight into the net, it is probably not the paddle's fault. It is the wizard, not the wand. But having a wand tuned to your specific physics certainly helps.
It absolutely does.
If you have a friend who is currently agonizing over carbon fiber weaves and millimeter thicknesses, definitely share this deep dive with them. You'll save them hundreds of dollars and an immense amount of frustration.
Yeah, understanding the mechanics of your equipment is the best advantage you can bring to the court.
And I want to leave you with one final thought to ponder. We've talked about how rapidly paddle technology is advancing, Foam-injected unibody thermoforming, pure trampoline effects, raw carbon fiber arms races.
It's moving so fast.
With the gear getting this incredibly powerful and the ball moving faster than ever, how long will it be until governing bodies have to step in and mandate a standardized wooden paddle rule?
Oh, wow.
Much like Major League Baseball requires wooden bats to ensure the sport remains a true test of human skill rather than a competition of who has the best aerospace engineering. Think about it. The absolute pinnacle of this space age evolution might just be sending us all the way back to 1965 playing with a heavy wooden cutting board.